sense of the process is find the gradient at the point and then plug it into the equation for the plane. There you go. That's all you need. You just need a normal vector and a point. Okay. So the second piece, can you do the second piece? Is that?
So
is that good?
The second piece is just when you use 8 or 0.
0, negative 8, negative 1. So in this one, you just plug in 0, negative 8, negative 1. Cool. Yeah.
Page number 48.
48. Horizontal tangent. So find the points where they have horizontal tangent planes. That's squared. Minus 2. Minus 2 is good. Minus 2, Jesus. Equals 0. So they want to know, where does this guy have horizontal tangent planes? Where will that happen? Where will that happen?
When fx and fy are 0.
And why does that make sense?
Because they're gonna be parallel to x, y, and y.
Because I want to be parallel to the xy plane.
Exactly.
So I don't want z to increase. I want to, at that point, I want z to just stay the same no matter if I go in this direction or that direction or some. So f of x, fy has got to equal 0 at that point. I love it. So what is fx?
2x minus 2.
Yeah, 2x minus 2. That's cool. And what's fy?
4y.
That's just that one, right? And when are those equal to 0?
When x equals 1 and y equals 0.
Yeah, this is equal to 0, so this makes this x equal to 1. When this is equal to 0, it makes it y equal to 0. Right? And are they asking for the actual? Find the points at which. Cool. So then, what are the points where they have horizontal tangent planes? So all you really need to do now is, I know the inputs, because I could solve this for z. It's kind of not the easiest thing in the world to do, but can't you put the x and y in and see what z is to finish out the point? So you have your inputs. X has got to be 1, y is equal to 0. All you're missing for a full point then is the z output. So plug in 1 and 0 for x and y and solve for z. You guys see that? So for example, if I plug in 1 for x, it's nice, so I get a 1. Y is 0, that kicks ass. So I get 1 plus z squared minus 2 minus 2z minus 2 equals 0. Now solve for z. You'll probably end up with something you can factor. Let's see, z squared minus 2z minus 3, right? And you can factor that bad boy. So you actually get a couple points. That's mighty nice of them, right? You get the feel for this? I mean, relate it back to what you did in calculus in past times. What would we do first to find a horizontal tangent line? Where a function has a horizontal tangent line, what would we do first? I give you some function. You would find the derivative. Z equal to 0. You get x equals something. And of course, that's not a point. To finish the point out, you would plug that back in to see what your output is. All right, well, I got two input pieces, right? X, Y. All I'm missing is what the output is to make it a complete point. So plug those in and see what z is. I'll get my 2 points. Right? How do you factor this thing?
Z minus 3.
I like it. So you get z equals 3, negative 1. So your 2 points would be what? 1, 0, 3. 1, 0, negative. I like it. Sweet. So the difference is, I'm not just finding a single input. Because my inputs are now at least 2 of them, right? But what you do with them once you find them is the same as it was before. Once I find what my input or inputs are, I put them in. And then I see what the output is. And there's my complete point. So tell me this, just to kind of look ahead a little bit. Since they have horizontal tangent planes at those 2 points, what else might happen at those 2 points? It might be max or min, some kind of extremum, right? Or it could be the equivalent of psyching us out, right? That's what the x cubed is a good example of psyching us out. Oh, I'm going to turn, no, not. So that's not really a max or min, but it is a location of a zero, a horizontal tangent line, right? So, yeah, so this would be what we call here an inflection point because concavity changes. In 3 dimensions now, it gets a little strange. There's a lot more kind of ways to psych us out. In one direction, it could do something. In the other direction, it does something else. And that's going to be something interesting related to this, right? So it kind of makes sense to be a true maximum. What's got to happen no matter which direction I go from that point? If I'm at the maximum, the function better freaking decrease. Now, if it decreases if I go this way, but it increases if I go that way, that's not a max or a min. That's a freaky thing. In fact, who remembers the name of that?
Saddle point.
Saddle point. And they call it a saddle point because it looks like a freaking saddle. Really. Right? I mean, the classic equation just looks exactly like a saddle. Right? You get the little piece that comes up, little pieces that go down, so you put your legs out there. Right? That's not how you get on a horse. Unless it's really tiny. In which case, that would be evil for carrying me around. So any other questions before we do some review, actually? No. What I want you guys to work on here for a little bit is just one side of this, the 12-7 quick quiz. So it's just going to be a little review to see how much you remember or know from 12-7.
I'm kidding. More like sitting at home. Like my cousins and carving. Oh.
I know it's really late.
Right? I was like, yeah. Really? What pumpkin have? They have like millions of pumpkins.
Guys, do me a favor also, make sure you got 2 sides to this. Everybody got 2 sides?
He looked this over, like he didn't see that I didn't even do what the problem was. And so he gave me credit for it. And I asked him because I didn't.
And explicit form is actually the same thing, it's just that we...
It's just rewritten. And they make a bigger deal out of it than they really need to.
Okay.
You could always write one in the other form and attack it with that method.
They even calculate the tangent the equation of tangent line, they're kind of different. Initial, they have like f of a and b, but then the general one doesn't have that. So
Well, you
it's
still
kinda-
plug the AB in. I think they just,
just bring it on top.
the only real difference is if you solve for z, your FZ is always gonna be one. Right?
Yeah.
If you don't solve for z, your FZ is gonna be whatever. So, you see what I'm saying? It's not,
It's kind of.
it's really not that big of a deal. They're the same.
Yeah,